Okay, so today we had solving quadratic tree, and I want to make sure that those of you who are absent can learn how to deal with quadratics, because solving simple is just getting rid of adding by subtracting and multiplying by dividing. But when you throw a quadratic in there, it's factoring. So each problem I go over with you that has a quadratic in it, it's going to be a different kind of factoring. So first of all, when I look at this, I realize there's no constant on the end. It's just a quadratic and linear term. So I'm going to take out the word cosine, and everywhere the word cosine or theta is, I'm going to put an x. So I set this over here to remind myself that I took that out, and I'm replacing it with x's, because I think it's easier to see what to do because we've done that before. So now I can see this problem has a GCF. So I'm going to take an x out. Now you're going to solve these all the way down before you put the word cosine back. So x equal to 0 is already solved. But 2x plus 1 equal to 0 is not solved. You need to do the opposite, just like you do in regular math. Minus 1 and divide by 2. Now if you can do that in your head, go right ahead, because obviously adding became subtracting and multiplying became dividing, and it made a fraction. Then you go back and you put in the word cosine of theta where the x is. And you look up on the unit circle, where is the cosine inverse 0? Now cosine is 0 at the top at pi over 2 and 3 pi over 2. And so you can just look up those answers. You don't have to, unless you're like me and you just have the unit circle memorized to where you can just think around and find it. If you're not, look it up. Now let's do cosine of this equal to negative 1/2. So I've got a cosine inverse this negative 1/2. Now cosine is only negative in quadrant 2 and 4, because that's, 2 and 3. And so I'm looking for where the first number is negative 1/2. And that's next to the...
May I have your attention, please?
So therefore, it's on each side of the x-axis here. And so that's 5 pi, well, my marker's not writing again. 5 pi over 6 and 7 pi over 6. And you can look at your unit circle and make sure I picked up the right numbers. Let's see. Yes, 7 pi over 6 and 5 pi over 6. No, I did not. I picked up the wrong ones. I was thinking sine. It's 2 pi over 3 and 4 pi over 3. See why it's important to look at your unit circle sometimes? I was thinking sine instead of cosine. So it's 2 pi over 3 and 4 pi over 3. So it always is important to look at your unit circle and double check it to make sure you're on the right track. So yesterday I did one like this one where there was no middle term, and most of all the problems I did yesterday didn't have quadratics in it, but I showed you how you could add one and square root it and it would give you the answer. But that's probably not the best way to do it. So let's look at this one. There's a quadratic and a constant term, no middle. That's food line. Because I can make me two parentheses. So let's put an x in for our cosine. It's a lot easier to factor food line if you see x's. So we know x times x makes x squared, and 1 times 1 makes 1, and a negative times a positive makes a negative. So that's food line. So we set x minus 1 equal to 0 and get x equals 1, and x plus 1 equal to 0, and x equals negative 1. Then we go back and put the cosine back. Where's the cosine angle 1? Where's the cosine angle negative 1? So we're thinking about that inverse again. Cosine inverse is 1. So cosine is 1 over here at 0. That's the only place it is. When you have the 1 number, you don't have lots of answers. And cosine inverse of negative 1 happens over here at pi, because it's negative 1, 0. So those are my two answers, 0 and pi. Most of the time quadratics give you 4, but when you're working with 1 and negative 1, you only get 2. So in our next example, we have all three terms. We have a quadratic term, we have a linear term, and a constant term. So let's let x be sine of theta and take it out and make the problem look like what it would be without the word sine, but have x's instead, because we're more familiar with x's. This becomes the 5-step method. And let's review. Step 1 is to multiply the first times the last and make a list for step 2. Well, I could have 1 and -2, or -1 and +2, or the only ways I can multiply to get -2. But how does it add up to -1? Well, it does that if it's -2 and +1. So that's the first 3 steps to the 5-step method. The 4th step is to put that in for your 2 linear terms. And I have real specific rules about what I do with that. For example, I have a negative and a positive. I always like my negative one to be in the second position, so I don't have to take negatives out. So then I split the problem and take out the GCF, which is 2x, and that leaves me with x minus 1. I already have x minus 1 over here, so I'm going to take out +1. So the 5-step method says do grouping in the 5th step, so I'm finishing off my grouping by taking out my x plus 1, and that gives me 2x plus 1 left. Now I have to solve those and then go back and find the sign of those answers. So x equals 1 and x equals -1/2. If you set it equal to 0 and solve, by this point in your math classes, you should be able to solve a 2-step equation in your head. If you can't, you can go back and you can show work like I was showing over here on this first example with 2x plus 1, but it's not that hard to do it in your head. So now I'm looking for where is the sine of theta 1. Sine is 1 up here at the top, so that's pi. And where is the sine of theta -1/2? And that would be in a place where the half is in the bottom half of the graph to be negative, almost 30 and 4. And so I believe that's at 7 pi over 6 and 11 pi over 6. Let's see if I'm right. We'll check our unit circle. Seven pi over 6 is -1/2, and 11 pi over 6 is -1/2. So in our next question, you'll notice I don't have quadratics. In fact, it looks like somebody's already factored it. Well, I'm sure glad they did, because that's 2 different words. That would be a whole lot harder to factor than having quadratics, linears, and constants. So you just simply take each one, set it equal to 0. So I'm looking for where the tangent is 1. And the tangent is 1 when the y and the x both cancel out. That's when they're both positive. And at 5 pi over 4, they're both negative, and they cancel out and make +1. So here is my solution. Now we know that tangents 1 means they canceled out, so we just look for those 4th lines and get those answers. So secant equal to 1 wherever cosine is equal to 1. And cosine is 1 over here on the edge of the graph. So in this case, theta is equal to 0 is my other possibility. So I got 3 answers out of that one. So what do you do when you have a mixture of words? Well, you would like to have it to have all the same words. And what I told my students over the years is it's not so much what you've got in the quadratic as it is what you have in the linear. If your linear is cosine, then your whole problem needs to be cosine. So we've got to figure out how to get rid of this sine squared of theta. Well, there's a rule on your formula sheet that says sine squared plus cosine squared equals 1. And we can manipulate that formula so that we can make it sine squared equals. And that way we could take out sine squared. So we're going to solve this for sine squared by moving the cosine and subtracting it to the other side to get rid of addition. That way, I can get rid of the sine squared and put in our new expression for it right here. So I'm going to substitute that in. 1 minus cosine squared of theta. It's already got a minus cosine squared of theta. And I'm going to say it's equal to 1 plus cosine of theta. Now we know quadratics have to be equal to 0 to solve because we're solving by factoring, and they have to be equal to 0. Well, since that's the case, when you solve quadratics, your quadratic term needs to be positive. So I need to move everything to the right. So I'm going to take 1 away. That made them all drop out. I've got 2 cosines here, so that's -2 cosine squared of theta. I'll just put those like terms together before I move them to the other side. Now, in order to get this -1 to the other side, I'm going to add 2 cosine squared of theta. That makes 0 equal 2 cosine squared of theta plus cosine of theta, because I cannot add those together. They're not like terms. One's quadratic and one's linear. This goes back and looks very similar to what we had on question number 1. Let's go back and see. As you can see, it perfectly matches up to question number 1. So since I've already showed you how to solve that, we're just going to put a note here that says, see question 1 to finish, to see how to finish. To see how to finish. Because we've already solved that once, there's no reason for us to solve the same problem twice in our notes. If we already have done that, you can just go back and look at how to finish it. So let's try that rule again. We just learned that sine squared is 1 minus cosine squared. So I'm going to put that in because my linear term over here, my linear term is cosine. Now I think that 6 needs distributing, so I'm going to go ahead and do that. And when I look at this, my quadratic now is matching my linear, so that's good, but it's negative. So let's take it to the other side. So let's -1 first. Add 6 minus 1 is 5. And let's add our cosine to the other side. That's squared. And we get cosine squared of theta plus 6 cosine of theta plus 5. So now it would be one of those times where I say, well, you know, I really should put cosine of theta is equal to x. I'm going to stop the video and answer the phone. Alright, so now I'm back, so I can put these x's in. X squared plus 6x plus 5. It's much easier to see that 1 times 5 is 5, and the only way to get 6 is to add 1 and 5 together. So I can go straight to plugging those in. I don't have to do the whole grouping process, and we talked about this back when we were factoring. If it starts at a 1, you can just fill it in. So x equals -1 and x equals -5 would be my factoring, but we've got to go back and set that equal to cosine of theta and find the angles. So where is the cosine equal to -1? Well, the cosine's -1 over here at pi. So there's one answer. And where is the cosine equal to -5? Well, if you look at the unit circle, the biggest number on there is 1. The cosine is never going to be equal to -5 because it has to fall between 1 and -1. So we mark that one out. I can't get a solution from that. So our only solution is pi. So here's going to be our last example of quadratics, and this one's a very big mixed problem. First of all, we have sine squared. So we might want to change that to 1 minus cosine squared, but I don't know yet. So I'm going to work on this part over here first. What am I going to do about this double angle? Well, when you look at your double angle on your formula sheet, and let's see if I can bring my formula sheet up. I had it earlier today. Trig formulas you need to know. Nope. That's not it. Well, maybe this is it. Well, come on. No, that's not it either. Well, okay. All right, so this is the one I was wanting to look at, I think. So I see here, well, maybe this isn't the one I wanted. You're going to hear some clicking in this video. I'm trying to find the formula sheet that we use in class, but I'm not seeing it. Well, if you look at your formula sheet,
May, please come to the office.
let me just get out of this and tell you the formula. I can't find my formula sheet, but there's a formula for double angles that we were talking about on the previous videos, and this is the one we used on the previous video. But if you look past that, there are two others, and that's the two that I want to talk about. See, I can't use sine squared plus cosine squared when I'm doing a solve problem. That's for evaluating. So I want to pick one of these over here. And since I already have sine in this question, it'd probably be better to pick the last one and say 1 minus 2 sine squared of theta plus 6 sine squared of theta equals 4, because at least it has the word sine in it. Now I can put my like terms together and get 4 sine squared of theta plus 1 equals 4. Now I could try setting that equal to 0. And if I did that, if I took the 4 away, that would make this negative 3. And that will not be factorable because it's not square rootable for food line. So sometimes solving by hand when there's a middle term missing might be the better way to go, because it works every time with no middle term. So we're going to take 1 away from both sides, and that's going to give us 3, and we're going to divide by 4. And that's going to give us sine squared of theta equals 3/4. And we're going to square root. And that's going to give us sine of theta equals the square root of 3 over 2. But we got to put a plus or minus on that because you just took a square root. So we're looking for all the sines that end up being square root of 3 over 2. So let's go back and look at our unit circle. The sines are square root of 3 over 2, a negative square root of 3 over 2 at all of the third lines. So 1/3, 2/3, 4/3, 5/3. So pi over 3, 2 pi over 3 are the two positive ones. 4 pi over 3 and 5 pi over 3 are the two negative ones. So in the next 3 questions, we're not going to have any squares. So these are a little bit more unconventional solving. And I'm going to have to stop this video for just a few minutes while the students come in for tutoring. And I'll try to finish this video for you. But these are very unconventional. All right, so in this problem, I don't have any squares, so I've got to use some different processes here. And the only trig that allows you to put sine and cosine together is tangent. Tangent is sine over cosine. So I've got to get this formula to where I can turn it into that. So I'm going to take my sine to the other side by adding it and divide by cosine. That makes it look like my tangent formula. Cosine divided by cosine is 1, and sine over cosine is tangent. That looks much better than what I started with because now I only have one word. Now tangent is 1 at pi over 4, because that's the square root of 2 over the square root of 2 for y over x, and at 5 pi over 4, because that's negative square root of 2 over negative square root of 2 is 1. So there are my two answers. So in this one, maybe I can try that same thing. Maybe I can put in sine of theta over cosine of theta. And you'll think, well, that didn't help very much because now you still have mixed words. Well, let's stick a 1 under this one and see what we can do with it. I'm going to cross multiply. If I cross multiply, the fractions go away, and I can bring that sign over to the other side by subtracting. And then this becomes a problem more similar to the first one. It's a GCF. Take out sign in both. Remember, when you take something out, there has to be something left. So if you took it all out, put a 1. Now set each one equal to 0. Again, if you want to put the x in to help you to see the solving, you can. X will be 1/2, and then you can go back and put in cosine back, or if you can do it with the cosine in, go right ahead. Now sine is 0 at 0 and pi, and cosine is 1/2 at pi over 3 and 5 pi over 3. So you can look those up on the unit circle and be sure that you're picking up the right numbers. I have my unit circle. Let's go back and see that, make sure I did that right. As you can see, sine is 0 at pi and 0, and sine is, what was I looking for? No, cosine. I was looking for cosine's 1/2 at pi over 3 and 5 pi over 3. Yes. So 0 and pi, and a pi over 3 and 5 pi over 3 is what we got. For our last example, we have a double angle of sine. There's only one formula for double angle of sine. So I'm writing down the formula that we have for that. 2 sine times cosine. And we're going to do kind of the same thing we just did on the last one. Take the cosine to the other side and subtract it so that you can factor it out. So where is the cosine 0? Well, that's at pi over 2 and 3 pi over 2. If you solve the second one for 0, that'll be sine is 1/2. And sine is 1/2 at pi over 6 and 5 pi over 6. So you can check behind me and make sure I got the right angles, but that's the idea behind solving, is to try to turn it into a factoring problem so that you can look up the solutions. So I have the assignment sent to you, or you can look for it on Canvas.